So when we design LED strip, the most common design differences are in how the individual LEDs are controlled. Specific differences in colour, whether or not each LED is addressable. So the LED strip that I'm looking in here is not an addressable LED strip. It is purely, when I put power onto the end of this, every LED that's on that printed circuit board will light up. It's not addressable. It is dimmable, but it's dimmable via the driver. Okay, so single colour, which this is, single colour, non-addressable. Every LED, single, ranging from 2200K up to 6500K, will all operate at the same time. Okay, we've got a bit of a chart there, and we've got a bit of a chart that you can see that the correlated colour temperatures. Okay, the next thing to look at is we have a dynamic tunable white, which is also called CCT. What that can do, it's still non-addressable, but what that can do, that can take us on the range from warm white through neutral white to white, and vice versa. So it becomes a CCT. There's multicolour non-addressable, which is our RGB and our RGBWs and things like that, which is something like that. Now, if you look at the LED strip here, the LED here, you can see you've got two copper dots. That tells me straight away that's a single colour. When you look here, and it might be a little bit hard with the camera, but you can see it's got multiple copper dots. Now that tells me straight away, if I was to put my glasses on, I can see that straight away I have got RGB, W and WW. So that tells me that I've got red, green, blue, white and warm white, which will give me a combination of the white and the warm white will give me neutral white. Okay, so, but here's something to look at. This is a single, it's basically, it's non-addressable, still not addressable, but look at the different LED strips. So this is a standard 4.8 single colour. This is now a multicolour LED strip. This one here is 4.8 watts per metre. This is 28.8 watts per metre. The one thing you'll notice is the width of the strip. Right, let's also look. One is very, very flexible. One is not. This one is not very, very flexible at all. Okay, so, but the width of the strip, the thickness of the strip is also very, very different. Okay, so, but if I want RGBW, I'll go for this one. If I want a single colour, I'll go for something like this. But what you have to remember is they are attached to a printed circuit board, and that printed circuit board controls and limits the flexibility of the strip and how the strip is going to operate. Okay, so it's not just grab a piece of strip, put a power supply on it and away you go. Okay, it's all DC. This is what we're looking at here is all 12 volt strip. Okay, so there's no, but the difference in the strip comes from what the chips are on the strip. Okay, so then once we go from the non-addressable, then we go to the addressables. The addressable, we got RGB, you've got RGBW, you've got RGB CCT. Those ones there are what they call addressable chips. So each chip can be told to turn on at a different time. Okay, so if you've ever seen LED chips that chase each other, that's what they call addressable chips. Okay, addressable LED strip. What we're looking at and what we have here is not. Okay, and we don't, very rarely do we actually sell a lot of addressable chips. That's mainly designed for theatres and things like that. Now, when we look at LED strip lighting, as you can see here, we've got our top ones which are brown, and then we go down to our white coated, which is what we have, a white coated LED strip. So we've got an epoxy across there. No, it's only IP20. Okay, so it's not weatherproof at that point there. It is still only IP20. However, this is what we would say would be a quality LED strip. Now, the brown, and we don't have a very good picture of it just here. The brown, which we can see at the top of your PowerPoint presentation there, is what we would class as being an open, it's an uncoated. So if you were to scratch that, you could damage the LED, the actual printed circuit board straight away. Okay, because it's uncoated, It has no resistance to any kind of water if it gets splashed or something like that. It still has a rating of around IP20, but its longevity would affect it because it doesn't have the epoxy coating. It's basically LED chips on a strip with a bit of lacquer across the top of them. Okay, and that's the difference. When it comes down to it, you can see the whole framework, you can see the whole the printed circuit board below that one. Whereas on the white one, you have to turn it a little bit to see because it's got the epoxy coating. All right. Okay, when we're talking LED strip design, we've got to look at the construction of the LED strip, because LED strip has to be fit for purpose. So when you're looking to do something with LED strip, you've got to work out what does your customer really want. You've got to ask a series of questions, which we go into when we're doing design. You've got to ask the questions, and then you've got to work out what is going to be the most fit for purpose and the most practical and economical LED strip to use. If you don't get the right one, you could be back. The customers gets, a little bit angsty sometimes. So, but the other thing to look at too is light output is based on the type of LEDs that are attached to the LED strip. Okay, so we've got, and we'll go into this a little bit deeper, a 3528. Okay, you'll see it's 50/50, and you'll see these numbers banded around all the time. What these numbers mean is the size of the LED chip. So a 3528 is 3.5 millimeters by 2.8 millimeters, so it's a little square. A 50/50 is 5 millimeters by 5 millimeters. Okay, now the size of the LEDs, a 5 by 5, you would assume straight away that that's going to be an RGB. Okay, because it's the size, and they'll have multiple terminals coming off it. Your 3528, yeah, look, that would be a non-addressable low power white. Your 5630 or your 5730, that would be a high output single color. And then you can also get a 50/50 SMD, which is also a single color, high efficiency, high CRI LED chip as well. The less common designs might have a 3014, 4014, 7020, 8020. Now these are big and they're less efficient and they're odd sizes. Okay, so what you want is you want to find an LED strip that has a common size LED, so you know it's getting used a lot. You're confident that it's going to give the efficiency because it's been tried and proven, and you also know then about the LED strip. You know how to install it, and it's nothing that's just been thrown at you and you've got to do something with. They all of those sizes will affect the brightness and the quality of the light that you get from every bit of LED. Okay, other types of LED strip. There is a thing called neon or flex. It's still an LED tape, okay, but it's constructed in a way to, if you've ever seen neon lights in the big drivers and power supplies that actually, or power generators that actually run the neon lights, this is an LED strip that is designed to replicate that. Okay, so it's silicone filled, it can be in a plastic channel, and it diffuses the light from the LED and just directs it out into one way and things like that. So it actually emulates an LED. Now the flex, or the LED tape, which is really flexible, may not be altogether straight. It might be like that. So you can actually bend it around corners and you can do everything you want it to do. Okay, so there is all of these other options that you've got to look at. So if you get a specific situation, you can go and buy or find your neon LED tape, or you can buy your flex LED, or you can get the conventional LED strip. Now, the circuit board and the composition and the quality for higher power LED strips, the quality and specification of the underlying circuit board. Now, let's just go back to our two samples here. The printed circuit board under this 28.8 watt per meter is thicker, it's wider to compensate for the other colors, but also to compensate for the additional heat, and it's wider, thicker, and the actual printed circuit board is actually bigger in surface area. Now, why? Because it compensates for the heat. It has to manage the higher wattage. Okay, whereas this one here is only 4.8, and it's quite flexible, but it will still kink. It will still do everything that you don't want it to do. So when we look at our LED strip surface, the high quality LED strips, they usually include an extra coating of white paint or epoxy to increase the reflectivity. So even though that's painted white, it is there for, to protect the printed circuit board, but it's also to provide that level of reflectivity as well. Even though they only come out at 120 degrees, it still does something. And it's a bit like in our downlight, when we've got the reflective material in our downlight. That's a similar thing. Okay, so the lower cost LED strips, we'll just skip those steps and probably give you a copper color coated exposed LED. It's a commodity LED strip. It normally comes at a budget price and things like that. Hey, it still works. It still emits a light, and if you can hide it, you can still get away with it.